Hey students, this is lesson 7.3, multiplying powers with the same base. We're going to learn some rules for multiplying products when they have the same base. Go ahead and do the vocab and I'll check back with you. All right, here's the rules we're going to use. When you're multiplying powers with the same base, you add the exponents. Just to give you a quick reasoning for that, let's say we have like 3 to the second and we want to multiply that by 3 to the third. Well, remember that 3 to the second is the same as 3 times 3, writing it as repeated multiplication. 3 to the third is 3 times 3 times 3, so if we count how many factors of 3 we have, you'll notice we have 5 of them. So, and what you can do is just add the exponents if you have the same base to get that. Go ahead and use the rules to do 11 through 14. All right, so let's go ahead and use those rules. Remember that 9 to the 5th means that there's 5 factors of 9, and 9 to the 3rd means there's 3 factors. So what we're going to do is total up the number of times we're multiplying by 9. So we're just adding the exponents, and that's 9 to the 8th. All right, so here we have -2 factors of -3, and here we have 10 factors of -3. So altogether, we're going to have -2 plus 10 factors of -3. Which is -3 to the 8th power. All right, you try that. Okay, so in these problems, we're just going to multiply it out and use that rule for multiplying powers when they have the same base. And think about this. This is the same as 6 times 3 times b to the 3rd times b to the -8th. So I can simplify the 6 times 3, just make that 18. And then I'm going to use my exponents and add my 3 plus -8, which is -5. But remember, to be simplified, we can't have any negative exponents. So remember that that equals 1 over b to the 5th, so I get 18 over b to the 5th for my final simplified answer. Okay, again here we can rearrange multiplication because it's commutative and associative, so I can write 4 times 3 times 2 times c to the 3rd times d to the 5th. And now I can simplify that. 4 times 3 times 2 is 24. C to the 1st times c to the 3rd is c to the 4th, and d to the 5th, and that's the simplified form. All right, you try that. All right, if they're in scientific notation, we can use some of the same ideas. Again, multiplication is commutative and associative, so I can rewrite this as 5 times 6 times 10 to the 6 times 10 to the -10. And now I can just simplify that, make it 30. And then I'm going to use my property that says if I have the same base, I just add the exponent. So I'm going to get 10 to the -4th power. And then I'm just going to finish by putting it back in scientific notation. If the numbers are written in scientific notation, then so should your answer. I'm going to change this to 3 to the 0. So I made that number smaller, which means I'm going to need to multiply by 10 one more time. So if you add 1 to -4, you get -3. All right, go ahead and try that, and I'll check back with you. All right, let's try another problem where we're using scientific notation here. It says the speed of light is about 3 times 10 to the 8th meters per second. How far would a beam of light travel in 8.64 times 10 to the 4th seconds, 1 day. To figure that out, we're going to take the number of seconds in 1 day, and then we're going to multiply that by how far it goes each second. So 3 times 10 to the 8th. And we're going to use, we're going to rearrange this and keep it in scientific notation. So I'm going to do 8.64 times 3 times 10 to the 4th times 10 to the 8th. And we'll use our power property that says if the base is the same, we can just add the exponents and get 10 to the 12th. Then I just need to multiply 8.64 times 3. And that's 25.92. And then just a last step, we want to make sure we have our final answer in scientific notation. So I'm going to move the decimal one place to the left. If I do that, I need to multiply by 10 one more time. So that makes it 10 to the 13th. Go ahead, you try that. All right, that's it. Go ahead and do the lesson check, and we'll talk about it next time we meet in class.